Hello! In this lesson, we will look at how to create an HR module model in K2 ERP. This will be the first lesson in a series where we will show, step by step, how the structure of a future application is created from scratch, from the ER model to tables, relationships, directories, and documents. Today, our task is to create the foundation of the HR module. We will not start writing code right away. We will not begin with the interface, and we will not rush into business logic. First, we need to describe the data correctly. This is where proper business application development begins. In K2 ERP, the structure constructor, K2 Builder, is used for this. This is the tool that allows you to create ER models, tables, fields, keys, relationships between tables, and later build full-fledged modules based on this structure. In this lesson, we will create an ER model for the HR component. In our case, this will be a model for working with candidates, recruiters, interviews, candidate statuses, projects, organizations, and departments. We begin by opening K2 Builder. Then, we go to the ER Schemes section. This is where data models are stored, models that describe the structure of future modules. We create a new ER scheme. Let's name it K2HR or K2ICHART, depending on which component name you use in your system. In this lesson, we will focus on the HR module, so the logical name is K2HR. If the name K2ICHART is already used in your environment, you can leave it. The main thing is that the name should be clear, should not duplicate other models, and should match the logic of the module. We do not enter the code yet. At this stage, we are working specifically with the data model. Later, when the structure is ready, we will be able to move on to generation, interface configuration, business logic, and configurations. After creating the ER scheme, we move to the constructor. Before creating new tables, we need to add several already existing tables to the model. They will be needed to create relationships. In the HR module, a candidate does not exist on their own. They can be linked to a vacancy or position, to a project, to an organization, to a department, to a recruiter, and to an interviewer. Therefore, we need to add to the model those tables that already exist in the K2 ERP system. First, we add the positions table. In the business logic of the HR module, we need to understand which position the candidate is applying for. For example, Python developer, accountant, sales manager, business analyst, tester, or department manager. We add the existing table. The name in the model is position. The physical table may be called type position, or may have another name depending on the structure used in your database. In the description field, you can write candidate position, or position directory for linking with the candidate. If the table name is already clear, the description can be short. At this stage, we do not add relationships yet. First, we simply connect the table to the ER model so that it is available for future relationships. Next, we add the projects table. In K2 ERP, a project can be used as an analytical dimension. For example, hiring an employee may be done for a specific internal project, client project, business direction, or team. We add the existing K2 project table. In the model, it can be named project. The description can remain simple, project to which the candidate or interview belongs. If the system already has a standard description for this table, there is no need to duplicate unnecessary information. Next, we add the organization. In many ERP systems, the organization is a key object. A candidate may be hired into a specific legal entity, company within a group, or branch. Therefore, we need a relationship with the counterparties or organizations table. In our case, the organization table may be K2K, or another table responsible for counterparties. In the model, we name it organization. In the description, we can write organization to which the candidate belongs. Again, for now, we simply add the table to the model without unnecessary relationships. Next, we add the departments table. The HR module must understand which department the candidate is planned for: sales department, accounting, warehouse, production, IT department, service department, or administration. We add the existing departments table. For example, K2 storage or K2S depending on your structure. In the model, we name it department. In the description, we write department to which the candidate belongs. This table will also be used for relationships. Now we need to add the employees table. This is important because in the HR process, there are at least two roles, recruiter and interviewer. The recruiter is the employee who manages the candidate. They create the card, control the stages, arrange interviews, and handle communication. The interviewer is the employee who conducts the interview. For example, if it is a technical interview, the interviewer may be a technical specialist or a team lead. If it is a final interview, the interviewer may be a director, HR manager, or department head. We add the existing employees table. In your system, it may be called K2 worker, K2 employee, K2K, or have another physical name. In the model, we name it employee. This table will be used for linking both the recruiter and the interviewer. Now that the main existing tables have been added, we need to check their key fields. For the positions table, we need the position identifier. This may be type position ID. It must be a key or at least a field through which the relationship will be established. For the projects table, we need project ID. For the organization, counterpart ID or another organization identifier. For the department, storage ID or department ID. For the employee, worker ID or employee ID. It is important that these fields are clear and properly named. Later, when we create the candidate table, these are the fields that will be used to create foreign key relationships. Now we move on to creating the first new table. This will be the HR status directory. Why is it needed? During the hiring process, a candidate goes through certain stages. For example, new candidate, CV received, initial contact, interview scheduled, technical interview, final interview, offer, accepted, rejected, or reserve. It is better to move these statuses into a separate directory. This way, we will not write statuses directly as text in the candidate card, but we'll be able to manage the list of statuses centrally. This is convenient for filters, reports, analytics, and future automation. We create a new table. The name is HR status. The physical name can be HR status or K2 HR status. In the description, we write candidate status. The table type is directory. We save the table. In the model, it appears in a different color because it is no longer an existing table, but a new table created within our ER model. Now we need to add fields to the HR statuses table. The first field is the status identifier. Let's call it HR status ID. This will be the primary key of the table. The data type is string or varchar with a length of 75 characters. In K2 ERP, string identifiers are often used, so we choose string 75. In the comment, we write candidate status identifier. We make the field required. Numeric, false. We mark it as the primary key. We save it. The next field is the status name. We name it HR status name. The data type is string. The length can be, for example, 100 or 150 characters. In the comment, we write candidate status name. We also make this field required because a status without a name makes no sense. Numeric, false. We save it. Now we add the standard service fields that are needed in almost every K2 ERP table. The first service field is create user. It stores information about who created the record. The data type is string, length 75 characters. The field can be required or filled in automatically by the system. In the comment, we write, user who created the record. We save it. The next field is update user. It stores information about who last updated the record. The data type is string 75. Comment, user who updated the record. We save it. Next, we add create date. This is the date and time when the record was created. The data type is date time. Comment, record creation date. We save it. The next field is update date. This is the date and time of the last update of the record. The data type is date time. Comment, record update date. We save it. Next, we add the active field. In K2 ERP, it is used to indicate whether a record is active. If the record is active, active equals 1. If the record is marked as inactive or conditionally deleted, active equals 0. This is important because in systems of this class, it is better not to physically delete records, but to make them inactive. The data type for active is integer. The default value is 1. The field is required. The comment can be record activity flag. We save it. The next field is comment or notes. This is a comment for the record. The data type can be text or a longer string. Comment. Comment. The field can be optional. We save it. And the last service field is IDSRC. It can be used to link the record to a data source, replication, or integrations. The data type is string 75. Comment. Record source identifier. The field is optional. We save it. At this point, the HR status directory is ready. We have created the table, added the primary key, the status name, and the standard service fields. Now we move on to the main table of the HR module, the candidates table. The candidate is the central document in our HR module. The process will be built around the candidate. They will have personal data, contact information, current position, desired position, recruiter, status, organization, department, project, and related interviews. We create a new table. The logical name is candidate. The physical name can be HR candidate or K2 HR candidate. In the description, we write candidate for employment. The table type is document. Why document? Because a candidate is not just a directory entry. It is a process object. It has a life cycle, statuses, history, relationships, and interview rows. In the future, based on it, we can create a hiring process, approvals, conversion into an employee, offer generation, and hiring funnel analytics. We save the table. Now we add fields to the candidate table. The first field is candidate ID. This is the candidate identifier. The data type is string 75. The field is required. We mark it as the primary key. In the comment, we write candidate identifier. We save it. Next, we add the candidate's last name. The field name is last name. Comment, candidate's last name. The data type is string. Length, 100 characters. It is advisable to make this field required because a candidate card without a last name will not be very useful. False. We save it. The next field is first name. This is the candidate's first name. The data type is string 100. Comment, candidate's first name. We also make this field required. We save it. Next, we add middle name. This is the patronymic or middle name. The data type is string 100. However, it is better to leave this field optional. Why? Because not all countries use patronymics, not all candidates provide them, and in international processes, this field may not be relevant at all. Therefore, numeric remains true. We save it. The next field is phone. This is the candidate's phone number. The data type is string. The length can be 30 or 50 characters because a phone number may contain a plus sign, spaces, brackets, hyphens, or an internal format. The comment can be candidate's phone number. It is better to leave the field optional because a card may be created before all contact details are known. We save it. Next, we add email. The data type is string 100 or 150. Comment, candidate's email address. This field can also be left optional, although in a real HR process, email is often needed. But for flexibility, we will not force the user to fill in all the data immediately. We save it. The next field is address. This is the candidate's address. The data type is string 250 or text. Comment, candidate's address. The field is optional. Here, it is better to allow a larger length because the address can be quite long. We save it. Next, we add current position. This is the candidate's current position. For example, the person currently works as an accountant, manager, developer, or warehouse manager. The data type is string 100 or 150. Comment: candidate's current position. This field should not be linked to the positions directory because the candidate's current position may be from another company and may not match our internal positions. We save it. The next field is current workplace. This is the candidate's current workplace. The data type is string 150 or 250. Comment: candidate's current workplace. The field is optional. We save it. Next, we add experience years. This is the candidate's experience in years. The data type is number or decimal. We can set precision to 2 decimal places because experience can be, for example, 2.5 years or 7.3 years. Comment: candidate's experience in years. The field can be optional. We save it. The next field is expected salary. This is the candidate's expected salary. The data type is number or decimal. Here, 2 decimal places can also be used. Comment: candidate's expected salary. The field is optional because salary expectations may appear later in the negotiation process. We save it. Now we add the recruiter. The field name is Recruiter ID. This will be a foreign key to the employees table. The data type is string 75 because the employee identifier is also a string. Comment: recruiter identifier. The field can be made required if, according to our logic, every candidate must have a responsible recruiter. In most cases, this is correct. We add a relationship with the employees table through the employee field. We save it. Next, we add the candidate status. The field name is HR Status ID. This is a foreign key to the HR status directory that we created earlier. The data type is string 75. Comment: candidate status. The field is required because a candidate must be at a certain stage of the process. We add a relationship with the HR status table through the HR Status ID field. We save it. The next field is expected position ID or type position ID. This is the position the candidate is applying for. Here, we already need a relationship with the positions directory because we are not talking about the candidate's current position in another company, but about our internal position for which we are considering them. The data type is string 75. Comment: position for which the candidate is being considered. We add a relationship with the positions table through type position ID. We save it. Next, we add project ID. This is the project to which the candidate belongs. The data type is string 75. Comment: project to which the candidate belongs. We add a relationship with the projects table through project ID. The field can be optional if not every hiring process is linked to a project. We save it. The next field is organization ID or counterpart ID. This is the organization into which the candidate may be hired. The data type is string 75. Comment: organization to which the candidate belongs. We add a relationship with the organizations or counterparties table. We save it. Next, we add department ID or storage ID. This is the department for which the candidate is planned. The data type is string 75. Comment: candidate department. We add a relationship with the departments table. We save it. Now we add the standard service fields to the candidate table. Create user, the user who created the record. The data type is string 75. We save it. Update user, the user who updated the record. The data type is string 75. We save it. Create date, the record creation date. The data type is date time. We save it. Update date, the record update date. The data type is date time. We save it. Active, the record activity flag. The data type is integer. The default value is 1. In K2 ERP, to mark a record as inactive or conditionally deleted, active equals false or active equals 0 is used. That is, we do not physically delete the record, but keep it in the system for history, control, and possible recovery. We save it. Comment, a comment about the candidate. The data type is text or a long string. Here, the recruiter can leave notes: where the candidate came from, what is important to consider, what agreements were made, and what the first impressions were. The field is optional. We save it. IDSRC, the record source identifier. The data type is string 75. This field may be needed for import, replication, or integration with other systems. We save it. At this point, the main candidate table is ready. We have created the central document of the HR module, added personal data, contact information, experience, salary expectations, and relationships with the recruiter, status, position, project, organization, and department. Now we need to create the interviews table. The logic is as follows. One candidate can go through several interviews. For example, the first interview with the recruiter, a technical interview, an interview with the manager, a final interview, a follow-up meeting, or an additional check. Therefore, interviews are rows connected to the candidate. The candidate will be the header, and interviews will be the detail or subordinate table. We create a new table. The logical name is interview. The physical name is HR interview or K2 HR interview. In the description, we write candidate interview. The table type can be defined as a document row or a subordinate table to the candidate, depending on the accepted structure in K2 ERP. We save the table. Now we add fields. The first field is interview ID. This is the interview identifier. The data type is string 75. The field is required. We mark it as the primary key. Comment, interview identifier. We save it. The next field is candidate ID. This is the relationship with the candidate. The data type is string 75. The field is required because an interview cannot exist without a candidate. Comment, candidate identifier. We add a relationship with the candidates table through candidate ID. We save it. Next, we add interviewer ID. This is the employee who conducts the interview. The data type is string 75. Comment, interviewer identifier. We add a relationship with the employees table. The field can be made required if an interview must always have a specific responsible person. We save it. The next field is planned date or interview date. This is the date and time for which the interview is scheduled. The data type is date time. Comment, interview date and time. It is advisable to make this field required for scheduled interviews. We save it. Next, we add interview type. This is the interview type. For example, initial, technical, HR, final, manager, follow-up. We can create a separate interview type directory, but for the first lesson, we will not complicate the model. We will make it a string 75 field and later define the values in the configuration. Comment, interview type. We save it. The next field is result. This is the interview result. For example, passed, failed, in progress, awaiting decision, rescheduled, candidate declined. This can also be made as a separate directory, but for now we will leave it as a string field and later configure the values in the configuration. The data type is string 75 or string 100. Comment, interview result. The field can be optional because before the interview is conducted, there is no result yet. We save it. Next, we add project ID. The interview can also be linked to a project. For example, if the candidate is being interviewed for a specific project or business direction. The data type is string 75. Comment, interview project. We add a relationship with the projects table. We save it. We can also add an interview comment or feedback field. This is a comment or feedback based on the interview results. The data type is text. Comment. Comment based on interview results. This is a very useful field because after the interview, the interviewer can leave a conclusion, strengths, weaknesses, recommendations, and whether it is worth moving forward. We save it. Now we add the standard service fields. Create user. Who created the record? Type, string 75. We save it. Update user. Who updated the record? Type, string 75. We save it. Create date, creation date. Type, date time. We save it. Update date. Type, date time. We save it. Active, activity flag. Type, integer. Default value, 1. We save it. Comment, general comment. Type, text or a long string. We save it. IDSRC, record source identifier. Type, string 75. We save it. At this point, the interviews table is ready. Now we need to check the relationships between the tables. We have the HR status table. It is linked to the candidate through the HR status ID field. We have the candidates table. It is linked to the positions table through type position ID or expected position ID. It is linked to the projects table through project ID. It is linked to the organization through organization ID or counterpart ID. It is linked to the department through department ID or storage ID. It is linked to the employees table through recruiter ID. We have the interviews table. It is linked to the candidate through candidate ID. It is linked to the employee through interviewer ID. If needed, it is linked to the project through project ID. This gives us the first proper ER model of the HR module. Now, let's explain the business logic of this model once again in simple terms. In the HR module, the main object is the candidate. The candidate has their data: last name, first name, phone, email, current position, current workplace, experience, and expected salary. The candidate has a status. For example, they may be new, waiting for an interview, going through a technical interview, receiving an offer, or being rejected. The candidate has a recruiter. This is the responsible employee who manages the process. The candidate can be linked to the position for which they are being considered. This is no longer arbitrary text, but a relationship with the position's directory. The candidate can be linked to a project, organization, and department. This makes it possible to build reports in the future: how many candidates there are for each organization, how many for each project, how many for each department, and at what stages they are. The candidate has a list of interviews. One interview may be initial, another technical, and a third final. Each interview has an interviewer, date, type, result, and comment. This structure already allows us to build a simple but useful HR process. Now, it is worth explaining why we did not start with the interface. In many systems, development begins by first drawing a form. Fields are added to the screen, then someone thinks about where to store them, then chaotic tables appear, then it becomes difficult to make reports, and later it becomes difficult to develop the system further. In K2 ERP, it is more correct to start with the ER model. First, we describe the data. Then, based on this data, we can build interfaces, documents, directories, reports, APIs, imports, exports, business processes, and analytics. That is, the ER model is the foundation. If the foundation is made correctly, the module can then be expanded quickly. For example, in future lessons we can add the candidate source: LinkedIn, website, recommendation, recruitment agency, Telegram, email, or internal reserve. We can add a table for the candidate's CV or files. For example, store CVs, portfolios, certificates, and test assignments. We can add a table for test assignments. It will include the issue date, completion date, result, score, and reviewer comment. We can add an offers table. For example, salary, start date, conditions, offer acceptance status. We can add a relationship with a future employee. If the candidate is accepted, an employee card can be created from their candidate card. We can add automatic notifications. For example, if an interview is scheduled for tomorrow, the system can remind the recruiter and the interviewer. We can add analytics. For example, how many candidates came in during the month? How many were rejected? How many passed the technical interview? How many received an offer? And what the average time to close a vacancy is. That is why it is important to build the structure correctly at the first stage. Now let's briefly go through the standard fields we added to the tables. Janvier is needed to understand who created the record. This is important for audit, history, and responsibility. Update user shows who last changed the record. Create date shows when the record was created. Update date shows when the record was updated. Active shows whether the record is active. If a record is no longer used, it does not necessarily need to be physically deleted. In K2 ERP, it is better to mark it as inactive. This is especially important for historical data. For example, if a candidate once went through an interview and then their card is accidentally deleted, we may lose important history. Therefore, active allows us to work with data more safely. Comment is needed for additional explanations. IDSRC may be needed for integrations, migrations, replications, or imports from other systems. Now let's pay attention to the data types. We make identifier string 75. This allows us to use flexible identifiers, GUIDs, or internal codes. Text fields such as first name, last name, position, and email are made string 100 or string 150. Address and comments are better made longer, string 250, string 500, or text. Dates are made date time because we often need not only the date but also the time. For example, for an interview, it is very important to know the exact time. Numeric fields such as experience or expected salary are made number or decimal. For salary and experience, 2 decimal places can be left. Active is made integer with a default value of 1. Now let's talk again about relationships. Relationships are what make our model not just a set of tables, but a connected business structure. When we add HR status ID to the candidate, we do not simply store the text at interview stage. We store a reference to the status directory. This allows us to change names, sort statuses, and build filters and reports. When we add recruiter ID, we do not simply write the recruiter's name as text. We refer to an employee in the system. This means we will be able to see all candidates of a specific recruiter, build recruiter workload reports, and analyze efficiency. When we add interviewer ID, we also refer to an employee. This allows us to see who conducts interviews, how many interviews are scheduled, and who has not yet left feedback. When we add project ID, we get a relationship with the project. This is important if the company hires people for specific projects. When we add organization ID and department ID, we get the organizational structure. This is important for large companies, holdings, networks, and groups of companies, where one HR process can serve different legal entities and departments. Now let's imagine how this model will work in real life. The recruiter opens the HR module and creates a new candidate. They enter the last name, first name, phone, email, current position, current workplace, experience, and expected salary. Then the recruiter selects the status, for example, new candidate. They select the position for which the candidate is being considered, for example, Python developer. They select the organization, department, and project. After that, the recruiter schedules the first interview. A row is created in the interviews table. The candidate, interviewer, date, and interview type are specified. For example, HR interview. The result is still empty or set to scheduled. After the interview is conducted, the recruiter or interviewer enters the result. For example, passed. They add a comment. Then a second interview is created, a technical one. It is conducted by another employee. Then there may be a final interview. At each stage, the candidate's status changes. and the system can already show how many candidates are at each stage. This is the foundation of the HR module. In this lesson, we are not yet creating a beautiful interface, but we have already laid the groundwork on which it will work. Now let's check whether we have all the main tables. The first one is HR status. This is the candidate status directory. The second one is HR candidate. This is the main candidate document. The third one is HR interview. This is the candidate interviews table. The model also includes existing tables: positions, projects, organizations, departments, and employees. This is enough for the first version of the HR module. Of course, in a real implementation, the HR module can be much broader. It may include vacancies, recruitment requests, approval stages, integration with email, Telegram, LinkedIn, job websites, CV storage, test assignments, evaluations, final offers, conversion of a candidate into an employee, training, onboarding, and HR documents. But today we are deliberately taking the first basic step. We do not need to draw the entire spaceship. We need to correctly install the first load-bearing structures. Now let's go through the path we have completed once again. We opened K2 Builder. We created a new ER scheme for the HR module. We added existing tables to the model: positions, projects, organizations, departments, and employees. We created the HR status directory. We added an identifier, status name, and service fields to it. We created the candidate table. We added personal data, contact data, current position, current workplace, experience, and expected salary. We added relationships between the candidate and the recruiter: status, position, project, organization, and department. We added service fields. We created the interviews table. We added the interview identifier, candidate relationship, interviewer, interview date, interview type, result, project, comment, and service fields. We checked the relationship logic. At this point, the first HR module model is ready. Now a few practical tips. First tip: do not rush to create unnecessary directories. If the values are simple and do not require separate logic, they can sometimes be placed in the configuration. For example, interview type or interview result at the first stage can be made as a string field with a set of values in the configuration. Second tip: candidate status is better made as a separate directory, because status is an important part of the business process. Reports, filters, funnel analytics, and possibly automatic transitions will be built on it. Third tip: do not store employees as text. Recruiter and interviewer must be relationships with the employees table. Otherwise, it will be difficult to build analytics later. Fourth tip: do not forget about service fields. They seem boring, but later they help you understand who created the record, who changed it, when it was changed, and whether it is active. Fifth tip: do not physically delete important business records. Use active for such cases. This is especially important for candidates, interviews, and HR history. Sixth tip: name fields in such a way that 6 months later it is still clear what they mean. For example, phone is fine, but candidate phone may be even clearer if the table has many contact fields. The same applies to position. Current position and expected position ID are different things. The candidate's current position is text. The expected or target position is a relationship with our internal position. Seventh tip: before creating a field, think about what it is: a directory, document, row, service field, or just an attribute. This approach greatly reduces chaos in the database. Let me emphasize once again, today we did not simply click together a few tables. We created a model of a future HR application. This model already answers the key questions. Who is the candidate? Which position are they applying for? Who is managing them? In which organization and department are they being considered? At what stage are they now? Which interviews have they passed or need to pass? Who conducts the interview? What is the interview result? When was the record created? By whom was it created? And is it active? A business application is built from answers to exactly these kinds of questions. In the next lessons, we will be able to build the interface based on this model. For example, the candidate form, candidate list, candidate card, interview tab, filters by status, recruiter filter, position filter, and project filter. Then we will be able to create a status change process. For example, candidate created, status new. After the first contact, contact established. After the scheduled interview, interview scheduled. After the technical interview passed. After approval, offer. After acceptance, accepted. We will also be able to create reports. For example, a candidate funnel by status. How many candidates are in progress? How many candidates were rejected? How many candidates reached the final interview? How many candidates were accepted? What the recruiter's efficiency is? What the average duration of the hiring process is? We will be able to integrate with a calendar so that interviews immediately appear in the schedule. We will be able to create notifications in Telegram or by email. We will be able to store CV files through VDoc. We will be able to create a change history to see how the candidate moved through the stages. But all of this is possible only when the first layer, the data model, is built correctly. This concludes the first lesson. Today, we created an ER model of the HR module in K2 ERP. We added existing tables for relationships, created the HR status directory, created the candidates table, created the interviews table, and laid the foundation for the further development of the HR application. In the next lesson, we can move on to creating the interface, how to create the candidate form, how to display the candidate list, how to add the interviews tab, and how to connect directories to selection fields. Thank you for your attention. If you are creating business applications in K2 ERP, start with the right data model, because it is the model that determines how easy it will be later to develop the system, add logic, build reports, and scale the solution.